Okay, welcome back to the second part of this tutorial on systems of equations. You can see the working from the previous example is still on the screen there. I want to encourage you to start to use multiple pages and more importantly multiple problems when you're working through particular exercises. So here we've already defined A and B. Now I'm going to insert not just a new page, we're going to come up here to Documents and actually insert a new problem. And when we do that, we're going to add a calculator page. You'll see that we get from problem 1 to problem 2. Now A on this particular screen hasn't been defined, so all our variables are cleared and we can start a new problem while keeping the same document that later we could save for reference down the track. So returning to this problem, we now have two equations that we know have infinite many solutions created by coincident lines. Again, similar techniques. If we try and solve these equations, and I'm going to use my template again here to try and solve two equations. The equations I have from the previous whiteboard tutorial are x plus 2y equals to 1, and the second equation was 2x plus 4y equals to 2. Again, if I come across, try and solve that for x and y, we will create a solution, but we'll create a very unusual looking solution. We don't get a numerical value for x and y, we actually get a value in terms of another variable, this parameter variable called C1. Now if I've already used a number of screenshots as well, a number of different calculations, you may get that being C2, C3, C4, whatever it continues, depending on how many times the CAS calculator has had to use a particular parameter. Now what we're meaning by parameters is that we do have a solution, but we have an infinite set of solutions based on whatever value you want to choose for C. So if C is 0, we get a particular solution. If C is 5.3, we get another solution. Okay, so these are an indication that we have solutions and we have an infinite set of solutions defined by this particular parameter. As I mentioned on the whiteboard tutorial, we don't just have any value for x and y, we have values for x and y that are defined by these equations. So depending on what value you choose for C will govern the value for x and the corresponding value for y. Let's have a look at our attempt to solve this by matrices. So again, if we were to define the matrix A, which is a 2 by 2 matrix, we have had this on the previous screen, so 1, 2, 2 and 4. And if we tried to find a to the power of -1, we'd get the information that, again, it's a singular matrix. So a singular matrix will tell you that you don't have a unique solution, but it won't determine whether you have infinite solutions or no solutions. Okay, so we need to use a secondary level, which is this RF command, reduced row echelon form. And again, we go to our templates, select our matrix here, and we're going to have 2 rows and 3 columns, and the values that we need are again our A matrix, so 1, 2, 2 and 4, and our constant matrix, the B matrix, which in this case is 1 and 2. If we get that, the CAS will again try and reduce this down, and it's reduced the first row to 1, 2 and 1, and the second row has become a row of zeros. So in actual fact, that second equation has become redundant, okay, and has cancelled out basically the x term, the y term, and the constant term. So the only information we have is that x and y are related by this one rule, and we know that to be the case because both of our equations are actually identical. Equation 2 is just a multiple, or in this case, twice of equation 1, 2 lots of equation 1. So when you're using the RF command, that row of zeros down the bottom of your matrix is your key information that tells you that you have not a unique solution and you actually have an infinite set of solutions. So that is the RF command, very useful for determining which type of solutions you have. That's all for this tutorial. Thanks.